So what's the real part then? We say that complex numbers are written in this standard form where they've got a real part, which is the real number that's by itself, plus some other real number that's being multiplied by I. And the real number that's being multiplied by I is actually what we call the imaginary part, right? So for this complex number, what's the real part? Everybody see that? Yeah, it's 3. What's the imaginary part? 7. Okay, how about for this one? What's the real part?
0.
Yeah, it's 0, right? It's like 0 plus 2i. And the imaginary part? 2. Okay, let's do one other one. How about if I do something like -4? What's the real part? What is it? -4. What's the imaginary part? 0. Okay, because there is no I term, right? So B, the imaginary part B must be 0. Okay. I didn't show you this though, right? Yes, Crystal. Say it louder. Radium. Yeah, IUM. Yeah. Radium. Okay, so I didn't show you this, correct? We hadn't gotten to this. Is that right? Okay, so here is a Venn diagram that puts these complex numbers into perspective a little bit. So all of the numbers that we dealt with earlier in the year, that entire set of real numbers that we subdivided up a whole bunch, fits in this one set right here, okay, the real numbers. So the real numbers really are just the complex numbers that don't have an imaginary part, right? So the real numbers, it's the subset of complex numbers for which B is equal to 0, okay? Where there's only a real part of a complex number, that makes a real number, okay? The pure imaginary numbers that we had been dealing with last time that we met, this page right here where we were calculating, I don't have the notes from our last time we met, but all these answers that we got when we multiplied these things out, we had some other answers over here where we were simplifying these. For example, we ended up here with, just look at just one of these. This gave us the square root of 5 times I, right? Where there's no real part, we call those pure imaginary numbers. Okay, if A is equal to 0, and then more generally, all of the complex numbers that have both a real part and an imaginary part are just regular old complex numbers, okay? All right, so let's look at some examples then, and the job here for you guys is you need to identify all of the 4 sets that apply to that number, okay? So what about this first one? Let's see, Jack, is that a pure imaginary? Let's just go through the list.
No.
It's not, you're right. Is it non-real complex? Yeah. No, you're right, because it is real, isn't it? Right? So it can't be non-real. Okay, let's work our way around here. Paige, what do you think? Is it complex? Say it again. It is, you're right. In fact, every number is complex, right? Every number falls into that big set on the previous page. Is it real? It is, isn't it? Okay, good. All right, so let's see. How about this next one? You guys just tell me here real quick as a group. Is it real? What do you think? Give me thumbs up, thumbs down, everybody. Real? This guy? No, it's not. How do you know right away it's not real? There's an I, right? So it can't be real. Is it a non-real complex number? Thumbs up, thumbs down. Yeah, thumbs up. You're right. It's not real, and every number is complex, right? So really it has to be one of those two things has to be true. Either it has to be real or it has to be a non-real complex, right? So it is non-real complex. Is it a pure imaginary? Thumbs down, right? Everybody agree? Thumbs down. How do we know? Because there's a real part. A pure imaginary would have no real part. Is it complex? Well, yeah, every number's complex. Okay. How about this guy? Pure imaginary, thumbs up, thumbs down. What's your vote, Elijah? Go thumbs up on that. Okay, good. Complex. Okay, yeah. Non-real complex. Yeah, good. Real? No. You got it. Okay, you got the idea. Okay, last one. This one we have to simplify a little bit, don't we? Okay. So what's this going to work out to be if I simplify it? Square root of -4 is what? No. What's it going to be? 2i. Yeah, there we go. Good. Good. 2i. And the reason for that is because we could rewrite the square root of -4 as the square root of +4 times the square root of -1, right? Square root of +4 is 2, and the square root of -1 gives me an I. But our rule of thumb here is if I have a negative inside a square root, I know I'm getting an I, and then I just simplify the rest of the square root, right? So what about this one? We get it to be 2i, and now we can see non-real complex. Give me thumbs up, thumbs down. Good. Pure imaginary. Okay. Complex. Okay. Real. Thumbs down. Good. All right, so I'm going to give you a choice here. So we could, I think I feel like, how far are you guys in the first assignment, the 4.4 practice 1? You're up to the last problem? Okay. Oops, let me get roll here real quick. I'm going to forget if I don't do this. Elijah, how far are you? Are you in the 4.4 practice 1? You haven't started yet? Okay. You haven't started yet. I'm assuming Crystal probably hasn't started yet. Let's see here. Anna's not here. Give me just one sec. Sorry. No, Madeline. No. Oops. Never mind. That one's. No, Jake. Oh, what am I doing? No wonder. God, I'm way off here. Got the wrong period again. No wonder those people aren't here. Okay. Crystal, Caden, okay. No, we're good. Okay. Paige, have you started I'm just getting how close are you? You finished it? Drew, how about you? You haven't started yet? Okay. It doesn't take long though, right? Pretty quick? Okay. Okay. All right. I think with this group, you guys are ahead. We're just going to stay ahead. I may not do the whole thing. I'll try to give you a little time here, but let's just at least get started on the next section. Complex numbers. There we go. Practice 2. Okay. So this one deals with the arithmetic of complex numbers. And I'm actually going to stop this video